If you're building for Quest in Unity, you probably noticed that AI is basically everywhere. And honestly, a lot of it gets explained in a way that sounds amazing and exciting, but not very useful. So in this video, I want to simplify the stack and focus on what actually matters. How can this actually help me build things faster? And I also want to be clear about what this video is and what it's not. This is not going to be deep coding, like a deep coding session, like a deep coding walkthrough where I take you and tell you how to put every single thing in their space so AI just works. This video is more about understanding the stack in more like plain language. I want to talk about what these tools are, what they actually do, why are people using them, and how can we use them in our Quest and Unity development. And for the detailed step-by-step development side, I think Dilmer has already done a very good job covering these tools in depth. So if you want the full implementation process, you should definitely check him out. What I want to do here is that I want to make the overall system easier to understand. I will not go for, can the AI build the app for me? Or will AI replace development? No. I want to talk about how do I reduce friction? How do I speed up my setup? How do I debug faster? How do I make content changes faster? Or even how do I make the handoff faster when I'm working with other people? Things very small, such as using AI for a pull request or something like that. That is what I want for this whole series. And for me, in order to start, I think we have 4 different things that we need to talk about. The MQDH MCP. You got it? Yeah. The Unity MCP exception, the Unity MCP extension, the AI building blocks, and the Immersive Debugger. Each one of those solves a part of the iteration loop. And as we go through them, I want to explain each term in simpler language. Because honestly, a lot of this stuff, it's so much easier. But anyway, let's start. The first thing that I'm going to do now is open the website for the MQDH. And in here, you can actually see what MQDH actually means. MetaQuest Developer Hub. Interesting, right? Basically, that is Meta's desktop tool for Quest developers. If you have done Quest development before, you probably already think as the Developer Hub as a place where you can manage device-related workflows. It's real close between the actual hardware and development. So remember, MQDH is not some abstract AI thing. It's just a Meta Developers Hub for Quest. Now, all right, let's go into what MCP is. And if we go into the website here, we're going to see that MCP is Model Context Protocol. I think that the best way to explain what MCP is by saying that you are basically giving tools to your AI agent for it to do things and not be stuck only in text mode. It sounds a little bit abstract, so here's what it means in practice. Instead of asking an AI chatbot like ChatGPT or Gemini or Claude a general question and hoping that it guesses correctly, an MCP-enabled assistant can actually use real tools to get real context. So basically, what it means is MCP is like giving tools to an assistant to do things. It can even be your browser, or it can be your calendar. There are many ways that you can use your assistant. And in the case of Quest, there are many AI tools that are enabled through MCP. Or in an even simpler way, what we want to achieve is that it is a way for an AI assistant to use real Quest developer tools instead of just giving general advice on what to do. This is the first thing that I want you to understand. This is not just an AI that knows about Quest. It is an AI connected to Quest development tools that can actually use them, including actions and information. In the case of Meta's MQDH MCP workflow, that includes things like searching the meta docs, fetching a specific documentation, pulling logs or logcat from a Quest device, taking screenshots from the headset, searching Meta's asset library, or even help with performance checks and analysis. And as you can see here in the quick start, Meta makes it really easy to start using these tools. Again, I'm not going to explain how to get your environment set up. You can go look at some of the millions of tutorials that are out there. But what I want to say is that one detail that makes this less abstract is that Meta exposes this through HCDV. It's also really interesting because there are two ways that you can do it. You can use the command line version if you feel like that's much easier to understand for you, or you can use the MetaQuest Developer Hub version. This is really useful because it means that you are not locked into just one interface. And this is where you see the real value of AI, because developers need documentations, you need logs, you need a screenshot, you need context, you need device context. So the main thing is that these tools are not asking you to implement something new into your workflow. It's more like it's giving you tools to speed up your development process, to make it easier for you to implement and to do things that you already do. A lot of Quest development is not just clicking and writing code in Unity. A lot of it is checking performance, reading the logs, finding out if the interactions are working correctly. And these things are things that you have to do. And AI can make this easier for you. But yeah, then you will say like, okay, yeah, I know I can use AI to make some code, to read and fix some problems that I have in my app. But let's go a step further, because this is just the first tool that I showed you. There's much more. And now I want to talk about how you can give Unity as a tool for your AI assistant. And we do this through the Unity MCP extension. This is where the workflow moves closer to the Unity editor itself. The Unity MCP extension basically means meta-specific tools integrated into the Unity MCP system. So instead of using MCP to just look things up, like in documentation, now you can use MCP to do stuff. So the MetaQuest Development Hub MCP helps you with external development context, you could say, while the Unity MCP extension helps you with repeatable editor work. So things that are tedious. So now you not only have access to information, but you can actually do things. And because it's made by Meta, it works perfectly in Quest development. You will have faster scene scaffolding, more consistent setup, less repetitive editor work, and in general, easier onboarding for tasks. And what does it mean for a developer? If MCP helps you gather context, the Unity MCP extension helps you automate repeatable tasks. And yeah, I mean, this is beautiful and sounds super fun, but then how do I actually do that, right? This is where the AI building blocks come into play. This is where actual AI-powered behavior happens. And this is also where a lot of people just try to overcomplicate things, because Meta has made it so easy to implement things that people just decide to complicate themselves. So I think the best way to explain this is to make it smaller, not bigger. In general, building blocks are pre-made pieces that help you add features without the need of designing a giant architecture. So if you want a shorter definition, including AI, it's basically ready-made shortcuts for AI development. And the meta documents talk here about different categories or AI categories that include LLM, object detection, speech to text, and text to speech. That matters because most people do not need to start with an advanced AI system. It's more about the feature that you want, which can be just a simple object detection system for a mixed reality prototype, or an LLM helper for onboarding, support, or guided interaction. These are really great starting points because it help you understand and are easy to evaluate. This is also where we start with the terms agent and provider. And the easiest explanation is this. The agent is the app-facing piece, and the provider is the backend behind it. So in very, very, very plain terms, the agent is the part your app talks to, and the provider is the AI doing the work underneath. So if your app wants to talk to an LLM, your app interacts with the agent layer, and that agent is powered by a provider in the backend. This is important because it helps people understand that they don't have to make the whole provider system, but they just have to focus on the agent itself. And as you can see here, Meta has already named them agents. And providers can point to different things or different backends depending on your setup. It can be cloud providers like OpenAI, Hugging Face, 11 Labs, or Llama API. It can be local services like Olama, or it can be an on-device inference system like Unity Inference Engine. Sometimes then the real question is not, does this feature exist? But the real question is more like, where is the inference happening and what trade-offs does it create? Like, you need to separate what your app is trying to do from where the model is actually running. So if I had to explain in reality how building blocks help developers, I would say that they help you test useful AI features without turning your project into an AI science project. You can start with one feature, you can start with one building block, test the feature, see if it actually works in your workflow, and decide if it's worth keeping. But don't get me wrong, these are amazing building blocks. Meta's object detection building block is not just a label on a screen. It works with pass-through or camera frames. It has confidence values, and it also has depth-related context. So you can start turning these 2D recognitions into an amazing mixed reality application. And once you have that application, I think the next thing that you need to know about is the Immersive Debugger. From my perspective as an XR engineer, I think this is the most important tool in the entire stack. It is also the easiest name to understand. Immersive Debugger basically means a debugger you use inside the headset. Why? Well, because XR is not a flat screen medium, so it's not easy to develop. And a lot of problems only fully make sense inside the headset. You can look at values the entire day and still miss the real issue because it depends on things that only happen when you wear the headset. Things like physical space, spatial placement, gaze, hand interactions, timing, comfort. There are many things. And this is why debugging inside the headset is so important. Basically, the Immersive Debugger helps you close that gap between building something and experiencing what it's actually doing. And I think it's important to say that this is not an MCP feature. And this is not the AI part of the stack. This is the runtime debugging part of the stack. So after you use these tools to create an experience, you can use the Immersive Debugger to actually go in them and test them, to understand what things are going well and what things need to be solved, which in reality is going to happen a lot because you're using AI. And it is funny because you're using AI to fix AI, and that's how the cycle works. And once you notice that you're using AI to fix what AI did, that's how the workflow is formed. So you can go inside your application, test all of the things that AI has made for you, and then decide what you want to keep, what you need to improve, and what you need to fix. As I said, AI helps you get external context. So this is what I wanted to talk about the workflow. And in the future, I plan to talk about each one of these tools a little bit more in detail. But for now, this is your workflow. This is your stack. And here is the best and simplest way to explain it. MQDH MCP helps you get external context. Then the Unity MCP extension helps you automate repeated tasks, like editor tasks. Within that, then the AI building blocks provide you with features that you can implement really easy. And they are really practical for testing things that you want to add to your application. And in the end, the Immersive Debugger helps you inspect and validate everything that you did and check that everything is working in the headset. So the stack is not AI did everything. The stack is I used AI in order to achieve this experience. The stack is I used AI to make my workflow easier and to speed up the process. This is the real story. So remember, this is not a magic tool. This is a practical system. A combination of many things that make your development much easier and faster. I don't care about AI for the sake of saying AI. I want tools that make me move faster, test easier, and debug clearly. And of course, that they keep my project cleaner. In the next video, I'll try to give more examples about how we can use AI to make something that actually really saves time. I want to do something repeatable, something useful, and something that I actually keep in my process. That is the direction of the series that I'm going to make. Thank you very much and see you in the next one.